A massive portion of global crops never makes it to a plate. Post-harvest loss wipes out huge swaths of our food supply, often because farmers simply cannot afford the electricity needed to keep their yield cool. Conventional electric refrigerators rely on constant, expensive power grids. In off-grid agricultural zones or areas experiencing severe summer heat waves, these units frequently fail or cost far too much to operate continuously. But there is a reliable alternative resting directly under the topsoil. This is a subterranean cold storage chamber, constructed entirely by hand using engineering techniques developed long before the invention of the power grid. Constructing it requires a very specific inventory: raw earth from the site, local sand, gravel, and unglazed, highly porous clay bricks. Arranging these common materials in the correct configuration creates an autonomous cooling system. It turns an empty trench into an electricity-free refrigerator that actively protects the harvest. Step 1 is moving the dirt. We begin by excavating a trench wide enough to accommodate our walls and deep enough to escape the ambient surface weather. The ground has natural thermal inertia. Topsoil fluctuates wildly with sun and frost, but deep earth stays perfectly stable. Dropping past the frost line, around 4 to 6 feet, taps into a constant 50 to 55 degrees Fahrenheit year-round. Once we hit that target depth, we level the floor with an even 6-inch mixture of local sand and coarse gravel. Do not skip the gravel. If groundwater seeps in after a heavy rain and finds nowhere to drain, it will pool, rise, and completely flood your stored crops. Hitting the stable temperature zone and securing proper drainage is the foundation. It guarantees that the structure stays reliably dry and isolated from the extreme weather happening above. Next, we lay the masonry using a double wall setup. We build an inner and outer ring, leaving a continuous gap of a few inches between them to create an insulative air pocket. These walls must be built using traditional unglazed clay bricks. Do not use concrete blocks or Portland cement, as they will ruin the entire cooling system. Clay enables evaporative cooling. Microscopic pores in the unbaked clay actively draw liquid water from damp sand in the wall gap. As this moisture evaporates into a gas, it physically pulls thermal energy from the air, dropping the internal temperature. Concrete prevents this completely. It is dense and non-porous, meaning it suffocates the room, traps ambient heat, and stops moisture transfer dead in its tracks. By combining the double wall layout with highly breathable clay, the structure itself becomes an active engine, continuously chilling the storage space using nothing but water and evaporation. With the walls up, we cap the structure using reinforced wooden beams and a heavy tarp covering the span. We then bury the entire roof under 2 feet of dense soil. This thick earthen ceiling is mandatory to absorb and block direct, intense solar radiation before it can penetrate the chamber. To keep the air fresh without electricity, we install a simple passive ventilation setup consisting of 2 PVC pipes, an intake and an exhaust. The intake pipe drops just above the floor. Dense, cool air travels down and settles at the bottom. As produce generates slight warmth, that lighter air rises to the ceiling and is forced out through the shorter exhaust pipe. The final tool you need to operate the chamber is a standard hygrometer mounted to the wall to track the internal climate. You are looking to maintain relative humidity between 85 and 90%. This specific range keeps leafy greens hydrated and root vegetables firm, but it is just low enough to prevent mold spores from taking hold, sealing out the harsh sunlight from above while ensuring steady, gravity-driven airflow below finalizes the system. The subterranean environment naturally regulates itself without any power. Up on the surface, the soil bakes under an intense summer sun, reaching temperatures that quickly wilt fresh crops. But descend just a few feet below, and you find crisp, hydrated vegetables resting in steady, cool air. Maintaining that exact cooling profile using modern commercial refrigeration requires massive upfront capital and continuous monthly utility bills. This chart shows the cumulative operating expenses over a 5-year period. Electric cold storage climbs steeply as energy and maintenance costs compound, while the expense curve for the clay brick chamber stays